Hi everyone, welcome to the first lesson of our new unit, Similar Figures. We're starting off here with a topic and a skill that you've already come across in this course and numerous times before in your math courses, junior high, higher elementary. What we're looking at here is proportional reasoning. Basically, it has to do with the word fractions and ratios, and also with cross multiply and divide. And why are we covering this? We're covering this because when we get into our similar figures, we're going to have to use some of the principles we learn about right now, or that we review right now, to solve for missing values. Just gonna go over this here, and I'll show you some tips. So you have at the very top here, a ratio is a comparison between two numbers measured in the same units. A ratio can be expressed in three ways as shown below. You can have a fraction, 9 over 16, in words by saying 9 to 16, or colon 9 colon 16. Typically in this course, we're going to be using the fraction form 9 over 16, or 3 over 4, or 2 over 7, etc., etc. Ratios like fractions can be simplified. Now, this is something that you have come across numerous times in math, I hope, and you might remember a teacher saying, reduce your fractions. When you reduce fractions, you're trying to find, well, here, if we do the example it's given, if you look at 150 over 15, you're trying to think to yourself, like, this, of course, is a fraction or a ratio. And when you reduce it, what you're trying to do is you want to determine what is the biggest number that both 150 and 15 can be divided by. And of course, you can see it in this case. They both can be divided by 15. And when you do so, 150 divided by 15 gives you 10. 15 divided by 15 is 1. Now, some people struggle with this skill, and I'll give you a little trick for you can tell if you're reducing fractions properly. I'll just go with even another, just to show you again how this might work. Let's say we have 15 over 20. Oh, and I guess I haven't said this, but this is old stuff. The top is called your numerator. The bottom is called your denominator. Now, hopefully you can determine that the biggest number that 15 and 20 can be divided by is 5. So what you can do is you can test it. So let's say I go 15 divided by 5. That would give me 3. If you go 20 divided by 5, you will get 4. Now, you're wondering, did I do that properly? Did I reduce? One thing you can do is you can take the 15 divided by 20 and type it into your calculator. So go 15 divided by 20 and hit equals or enters, and that will give you 0.75. If you go to your number over here, your reduced form, you want to check to see if you've done it properly. If you go 3 divided by 4 and hit enter or equals, you will get 0.75. Well, what happens if, let's say, you didn't do it properly? So I'm going to let everyone know that I'm going to make a mistake here. So let's say I divided by 5 like I was supposed to, but I'm going to make a mistake. 15 divided by 5 is going to be 2, and 20 divided by 5 is going to be 4. Well, if you do your test, 15 divided by 20 still gives you 0.75. 2 divided by 4 gives you 0.5. Now, this decimal does not equal this decimal, therefore you know you have reduced wrong, and you no longer have equal fractions or ratios. That's just a little test. But now, there is a skill you have to have here, and the skill is, can you find the biggest number that both are divided by? So again, if I did, let's say, 10 over, I don't know, let's say 25, you have to be able to determine that the biggest number they both can be divided by is 5 in this case. So 10 divided by 5 is 2, 25 divided by 5 is 5. And if you check the number, if you went 10 divided by 25, that would be 0.4. If you go 2 divided by 5, that is 0.4. That is just a way of reducing fractions. Now, if we come down here, it says, if two ratios are equivalent or equal, the first or top term of each ratio compares to the second bottom term in an identical manner. You can represent this equivalence in the two ratios. So you see, this is what they did here. So if you take 150 divided by 15, and as you might remember, we divided them both by 15. 15 is the biggest number they both can be divided by. Well, if you do so, what you get is 10 over 1. And you see, these are called equivalent ratios. or in other words, a proportion. And how do you know that? If you go 150 divided by 15, try it. In your calculator, go 150 divided by, remember, the fraction line means divided by. So if you go 150 divided by 15, what do you get? Well, I think you get 10. Now go on this side. Well, what's 10 divided by 1? 10. So you do have equivalent ratios or a proportion. If I showed you that again, you could write this. Let's say you have 6 over 12. Well, if you reduce that fraction properly, you would divide them both by 6, and you would get 1 over 2. Now check it. Go 6 divided by 12. That should give you 0.5. Go 1 over 2. 1 divided by 2. It should give you 0.5. If both give you the exact same answer, you know you have equivalent ratios or a proportion. Now, this is just review down here. Cross, multiply, and divide. We have used this numerous times in this course. But remember, what you're trying to do, everyone, is, because you're going to use this skill throughout this unit. I'll just do a very easy one here. Okay. What I do when I do cross, multiply, and divide, or when I have two equal ratios, okay, you see this fraction is equal to this fraction. So they must be the same. So we're trying to find which missing value of x makes this true. Well, what I do, I'll just get rid of that there and I'll put back the equal. Okay, so what I do is I make two diagonal lines. And it does not matter how you do this, but the point I'm trying to make to you is, so ask yourself this, in which diagonal do you have both numbers? Well, that would be this one. So in your calculator, go 2 times 4 and hit equal or enter. It should give you 8. Now, divide by the number you have not used. So divide by 8. Your final answer should be 1. And that means your missing value in this case will be 1. And I'll show you why. Because what we had is we had x over 2 equals 4 over 8. And I'm telling you that x value is 1. Well, 1 over 2, does it equal 4 over 8? Well, if you go 1 divided by 2 in your calculator, that is 0.5. And if you go 4 divided by 8 in your calculator, that is 0.5. So that does work. I will show you another example. This is a very easy skill, everyone. I'm sure you've done it many, many times. Let's go, I'll put the x somewhere else. Let's go 3 over 7 equals 2, let's go 12 over x. So what you do, I'll do it a little bit lighter this time. So you make your two diagonals, and what I say to you is, find the diagonal with both numbers. So you should see 7 and 12. Those must be multiplied. So you're going to go 7 times 12, and you're going to hit enter. And what you're going to get, oh shoot, I'm always trying to double check my math, and then I made a mistake on my calculator here. So 7 times 12 should give you 84. Now, what do you do next? Take that value and divide by the number you haven't used, which should be the 3. Divide that by 3, and you get 28. So x should equal 28. Let's now do our check and make sure this works. So we have 3 over 7 equals 12 over 28. So let's make sure it works. What is 3 divided by 7? 3 divided by 7 is about 0.42. What is 12 divided by 28? It is the exact same thing, 0.42. Nonetheless, everyone, the ability to cross, multiply, and divide is going to be crucial to this course, and we will give you some practice for that now.